Hello everyone, welcome back to this exercise series for chapter 6 from our BUS 325 investment course. Again, we are continuing with the exercises. Remember that the questions from 8 through 12 are all connected, but we are skipping question number 9 because it's asking you to graph, and I don't really require you to graph, so you might find this particular question a bit strange. I'm going to run through the following 3 questions, 10, 11, and 12, in one video because they are interconnected. Okay, so in this video, we're going to cover 10, 11, and 12, and we're skipping 9 because it just requires you to graph the capital allocation line, and I don't really require to do that. As I explained in the class, I just want you to understand the graph. I would never ask you to graph it. Okay, so let's see what question 10 wants. What is the reward to volatility ratio of the best feasible capital allocation line? Now here, it would not make sense to you because the inputs are missing. So I'm going to give you the inputs. Just remember that for Sharpe ratio, or the reward to volatility ratio, reward to volatility ratio, we calculate it by calculating the risk premium over the standard deviation of the portfolio, right? And for this particular question, the inputs that you should know or should be given to you if you get a similar question would be all given. So you would be given the expected return on the portfolio, you would be given the risk-free rate, and you would be given the standard deviation on the portfolio. So what are these data for this particular question? The expected return on the portfolio, which is the complete portfolio, is 12.88%, and the standard deviation on the portfolio is 23.34%, and the risk-free rate, as you might remember from the previous video, is 5.5%. Okay, so knowing these inputs, you can simply substitute in your formula, your Sharpe ratio, or find out your Sharpe ratio. So here we'll have 12.88 minus 5.5% over 23.34. Okay. Now, make sure that if you use decimal format, you should use decimal format for both the numerator and the denominator. And if you use percentage format, you should stick to that throughout your substitution. Where do students make mistakes is that they would substitute, for example, the top part or the numerator and present it in a decimal format, and then for the standard deviation, they would write it in a percentage form, okay? Or vice versa. So make sure it has to be, because this is a fraction, a ratio. So if you substitute in percentages at the top, you need to substitute also in a percentage format for the bottom, okay? Now let's run the numbers. 12.88 minus 5.5, that would be 7.38, divided by 23.34. Okay, and we get 0.3162. So this is Sharpe ratio for our portfolio. Okay, now let's move on to the following question, question 11. It says, suppose now that your portfolio must yield an expected return of 12% and be efficient, that is, on the best feasible capital allocation line. What is the standard deviation of your portfolio, and what is the proportion invested in the treasury bill fund and each of the 2 risky funds? Okay, Again, we'll go now to the equation of the capital allocation line, if you guys remember it, for the complete portfolio. The expected return of the complete portfolio would equal the risk-free rate plus the expected return on the portfolio minus the risk-free rate over the standard deviation of the portfolio. Okay, and then multiply that by the standard deviation of the complete portfolio. All right, notice how this is identical to the reward to volatility ratio, which we have already calculated here. Okay, so now using that fact, we don't really need to calculate it again. We'll just say equals 5.5 plus 0.3162, which is this, the answer to the previous question, okay, multiplied by the standard deviation of the complete portfolio. All right. And we don't really know this right here, but it was given to us in the question. The question is telling us that you want a portfolio, okay, that must yield an expected return of 12%. So we can set this to equal 12%. Okay, so let's write it down. Setting the expected return on the complete portfolio equal 12%. Okay. Now we substitute, okay, so we can go back to our formula and say 12% equals 5.5% plus 0.3162 multiplied by the standard deviation of the complete portfolio. Okay, simplifying this, you're going to move the risk-free rate to this side and turn it into a negative. Okay, I don't have enough space here. I'll try to, let me move the following question a little bit to the bottom so we can show you step by step. Okay, so that means I will have 12% minus 5.5% equals 0.3162 sigma complete portfolio. Okay, 12 minus 5.5, that would be 6.5. So 6.5% equals 0.3162 sigma C. And now I'm going to divide both sides by 0.3162. Okay. Again, we'll push this a bit further down. Sorry for that. So let's see. 0.065, which is 6.5%, divided by 0.3162. Okay. Notice what I've done here. Because I'm dividing these numbers by each other, in my calculator, I transformed this into a decimal format, okay? Because it doesn't, it's gonna give you a misleading answer if you keep it this way, okay? In fact, let me change it here, just so you understand. So 0.065, okay? And that have given me that standard deviation of the complete portfolio equals 0.2556, something along those lines. Okay, oh, sorry, my bad. It's actually 20.2056. Okay, which is equal to 20.50, sorry, 20.56%. Okay, and that would be the expected standard deviation of the complete portfolio, 20.56%. Okay, that is the answer to question 11. Now for question 12, it says, if you were to use only the 2 risky funds and still require an expected return of 12%, what would be the investment proportions of your portfolio? Compare its standard deviation to that of the optimal portfolio in the previous problem. What do you conclude? Okay. So now, using only the stock and bond funds, let's write that down. Using only the stock and bond funds to achieve a mean of 12%, we need to solve for the following formula. 12 equals 15 multiplied by the weight of stocks, which is 15 is the expected return on the stock fund, if you remember, plus 9, which is the expected return on the bond fund, multiplied by 1 minus the weight of the stock fund, which is going to represent the weight for the bond fund, which is 100% minus whatever we allocate to the stocks, right? Okay. And then we solve. We simplify this and solve for the weight of the stock component. Once we figure that out, we can find what would be the allocation to the bond fund. Okay. So now this will equal 9 plus 6 multiplied by WS. Okay, and from there we can derive that the weight for the stock fund equals 0.50, which is 50%. All right. I hope it's clear what I have done here. I've only distributed the 9 here to these. So 9 multiplied by 1, that would be 9, minus 9 multiplied by WS, that would be negative 9 WS, right? And then you simplify using your math skills. Okay. Now, knowing that we are going to allocate 50% in the stocks, that means the fund or the bond fund will also get another 50, the other 50%. Okay. So let's write that down. Let me add one more page here, just to have a complete answer. So investing 50% in stocks and 50% in bonds yields a mean of 12% and standard deviation of sigma portfolio, which should equal again applying our rule, our formula, the weight of the stock component would be 0.50 squared multiplied by the standard deviation, or sorry, the standard deviation of the stock fund squared, which, if you remember, we calculated before in the covariance matrix. I'll take you back to it just to show you, so you know where we got this from. Where's our matrix? Right here, 1024. Okay, so we'll use that information just so we don't repeat ourselves. Or you could just say, what was it, 32% squared, which was the standard deviation of the stock fund, but just for time saving purposes, plus 0.50 squared multiplied by the standard deviation of the bond fund squared, which was 529, if you guys remember, again from the covariance matrix, or 23% squared. Okay, same thing, plus 2 multiplied by 0.50 multiplied by 0.50. This is the weight of the stock fund, and this is the weight of the bond fund, multiplied by the covariance. The covariance was 110 point something. Let me see. Yes, 110.40. $110.4. Okay, all to the power of 1/2. Okay, now we simplify this calculation, and you should get, and again, just make sure that you do this one term at a time. Okay, so let's see, 0.5 to the power of 2. That gives us, actually, let me just multiply right away. So 0.5 to the power of 2 multiplied by 1024. That would be 256 plus 0.5 to the power of 2 multiplied by 529. That would be 132.25 plus 2 multiplied by 0.5 multiplied by 0.5 multiplied by 110.4. That would be 55.20, all to the power of 1/2. So I'll add these together now. 256 plus 132.25 plus 55.20. Okay, that gives me 443.45. Take the square root of that. We get 21.06%. Okay, so what does this mean? It means that the efficient portfolio with a mean of 12%, let's write that down. The efficient portfolio with a mean of 12% has a standard deviation of, what was the standard deviation? here 20.56%, okay, because it had a risk-free component. So we could say deviation, a standard deviation of only 20 point, sorry, what was that? 20.56. %, which is, let's see how many points that is. 21.06 minus 20.56, that's 0.50, okay. So including, I would say thus, including a risk-free component in our portfolio, reduces standard deviation, by 50 basis points, while as expected to generate the same return of 12%. Okay, I hope that is clear. Notice how when we had a risk-free component in our portfolio, the complete portfolio standard deviation was 20.56, okay? Whereas once we taken out the risk-free component and we created a portfolio of only stocks and bonds, we created the portfolio 50% of stocks and 50% of bonds, the standard deviation was a little bit higher. It was 21.06%, okay? Even though both portfolios are expected to generate a 12% return, right? Okay, that exercise shows us the benefit of having a complete portfolio, like we have explained in the lecture, that consists of a risky component, in this case the stock fund and the bond fund, and a risk-free component, which is in this scenario the treasury bills. Okay, I hope you found this video useful. We have answered 3 questions in this one. Again, we calculated the reward to volatility ratio, which is Sharpe ratio. Okay, we found the expected return on a complete portfolio that includes a risk-free asset. Okay, and we found its standard deviation as well. And then we assumed that we are constructing another portfolio without the inclusion of a risk-free component. We found the optimal allocation weights to be 50% for the stocks and 50% for the fund, for the bond fund. And based on that, we found since we are aiming or targeting the same expected return of 12%, we managed to find the standard deviation of that portfolio. Then we compared the differences between the standard deviation of the complete portfolio and for the risky portfolio. Okay, and we found about 50 points or 50 basis points difference between the two, even though both portfolios are expected to generate a return of 12%. All right, I hope this is clear. If you have any questions, please do not hesitate to drop them down in the comments. Thank you so much for watching, and I'll see you in the next exercise. Until then, take care.